In this video, we're going to be taking a look at how to create tree diagrams as a way of assisting us in determining total number of possible outcomes and calculating probabilities. So tree diagrams. What exactly is a tree diagram? Let's say that we are interested in a probability problem where we have a number of marbles, let's say in a bag. For example, we have a number of marbles in a bag, and let's say there are 3 red marbles, there's 2 yellow, and 6 green, okay, in our bag. And we're going to draw 2 marbles one at a time without replacement. And I might want to know what is the probability of drawing at least 1 yellow. Okay, so here's the scenario that we're dealing with. Now, we could use the multiplication rule of counting to come up with our total number of possible outcomes. We would, we have 3, well, if we look at this, there's 6, 7, 8, 9, 10, 11 total marbles. So we have 11 to choose from on our first draw, 10 to choose from on our second draw, and then 9 to choose from on our third draw, and we could multiply those together and that would tell us how many different possible combinations there are. The problem is that we do have some repeated outcomes here. These are not necessarily distinct, right? There's 3 red. All 3 of those, for all intents and purposes, are the same kind of outcome. And it can't help us determine what the probability of drawing at least 1 yellow is, because even though it can tell us the total number of possible outcomes, we don't get to see what those outcomes are. That's really the drawback of the multiplication rule of counting. We get to know how many there are, but we don't get to see what specifically they are. Now, certainly we could start listing these. I could get red, red. I could get red, yellow. I could get red, green. I can get, so on and so forth. But the problem with that is it's quite possible that I might miss one of my outcomes doing the listing that way. So a tree diagram is a really orderly way to organize the flow of a scenario like this. So you can not only find out how many possible outcomes there are, you can also use it to calculate probabilities, and you can see what all of the outcomes are. Now, the way to create a tree diagram is we're going to put a dot over here on our paper, and you want to leave yourself some space because this tree is actually going to grow as we move from left to right. So if you start it, right here, you're going to be growing your tree over your writing. So leave yourself some space, and we're going to label this the start. Now, on our first draw, we have to think of each draw as a separate event. What are my possible outcomes on the first draw? Well, I could pick either a red marble, a yellow marble, or a green marble. So I have 3 different possible outcomes: red, yellow, green. And I'm just going to use R, Y, and G to signify those. We'll take care of the probabilities in a minute. But on the first outcome, these are the only 3 things that could occur. I could draw a red, I could draw a yellow, or I could draw a green. And that's the first choice. Now on our second choice, same idea. Even if I chose the red one first, I could still get a red, yellow, or green on my second draw. If I choose a yellow first, I can still get a red, yellow, or green on my second draw. And if I got a green first, red, yellow, or green. So this would be my second choice. Okay, first choice, second choice. Okay, so right now this is the tree diagram itself. So for each choice, we get a set of branches. First choice, second choice, And if we want to know what all of the possible outcomes are, we can simply read along each branch from left to right. So if I start here and follow this top branch on both, that would represent drawing a red, red. Then here, following along red, drop down to the next branch, yellow, red, yellow. Then red, green. Okay, and that takes care of all those branches. Then I would have yellow, red, if I followed this branch, then yellow, yellow, and then yellow, green. Then I'd have green, red, green, yellow, and green, green. Okay, so those are all of my possible outcomes. Not only do I get to see the flow of the outcomes represented in a nice succinct format, but if I want to know what any of those outcomes are, I can simply list them out by following my tree from left to right. Now, probability of drawing at least one yellow. Periodically when people get to here, they go, okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 outcomes, and 1, 2, 3, 4, 5 of those have at least one yellow, so therefore it's a 5 out of 9 probability. I see people do that a lot. That is actually not correct reasoning, because that would be assuming that all of these outcomes are equally likely. But as you can see up here, these are not equally likely outcomes. We're far more likely to draw a green, we're actually twice more likely to draw a green than a red, and you're 3 times more likely to get a green than a yellow. Okay, yellow is the least likely outcome. So if we tried to just count up how many had at least one yellow and divide by the total of 9, we would be getting an incorrect probability here. So the next thing that you can do with your tree diagram once you get it set up is you can actually label it with its respective probabilities and use that to compute your outcomes. So for example, on this first draw of a red, on my first draw, there's 6, 7, 8, 9, 10, 11 marbles in the bag. And out of those 11, there are 3 reds for me to choose from on my first draw. With the yellow, if I were to select yellow on my first draw, I have a 2 in 11 chance of doing that because there's 2 yellows out of the 11 marbles. And selecting a green first, I have a 6 out of 11 chance of doing that. To make sure that you've set this part up correctly, when you read down this set that are all aligned in a column, it should total to 1. Because this represents our sample space for the first draw. So 3 11ths plus 2 11ths would be 5 11ths plus 6 11ths is 11 11ths. So that totals to 1. Now, when we go to put the probabilities associated with the second draws, we have to take into account what came before. So the probability of getting a red on my second draw, if I already got a red on the first draw, there would now only be 2 red marbles and there would only be 10 reds left in the bag. So I would now be down to a 2 in 10 probability here. To get a yellow after selecting a red, there would be 2 red marbles out of the 10. And to get a green after selecting a red, there would be 6 red marbles out of 10. And again, if you total those up, 6, 7, 8, 9, 10 out of 10. Okay, should total to 1 for this set of branches right here. If we move down to having gotten a yellow first, yellow and then a red, out of the 10 that are left in the bag, 3 of the reds would still be there. If I drew out a yellow first, all my reds would still be remaining. To draw a yellow after drawing a yellow, there would only be 1 yellow marble left out of the 10. And to get a green after a yellow, there would still be all 6 green out of the 10. 6, 7, 8, 9, 10 out of 10. So there's my total of 1. And then for this last one here, to get a red after having gotten a green would be 3 out of 10. To get a yellow after having gotten a green would be a 2 out of 10. And to get a green after having gotten a green would be a 5 out of 10. And certainly you could reduce these, but it makes it harder to see that they do add to 1. So 5, 6, 7, 8, 9, 10 out of 10. Okay. So those are the probabilities with each of these respective outcomes. Now what I'm really interested in are these events where I've drawn at least 1 yellow. So that would be this one, this one, this one, this one, and this one. Okay, those are the ones in which I have drawn at least 1 yellow. 2 reds is not at least 1 yellow. Red green is not at least 1 yellow. Green red, nope. Green green. Okay, but these ones all have at least 1 yellow. Now to find out the probability of each of these, probability of getting a red and then a yellow, that's an and probability. Red and then a yellow. So I would multiply these two probabilities together. I would take this 3/11ths here times this 2/10ths here, and that's going to give me probability of red followed by yellow. If I do that, 3/11ths times 2/10ths, and convert it into a fraction, I'm looking at 3 out of 55 for that outcome. The next one I'm then interested in is yellow followed by red. 2/11ths, 3/10ths, should be the same probability in this case. Yes, it is 3 out of 55. Then I'm interested in yellow followed by yellow. So 2/11ths times 1/10. And that gives me 1 out of 55. And then yellow-green, that's my next outcome here, would be 2/11ths times 6/10. That gives me 6 out of 55. And then this very last one, green followed by yellow. So green followed by yellow here. 6/11ths times 2/10 gives me 6 out of 55 again. Okay, so those are all of the individual probabilities of each of these. Red, yellow, yellow, red, yellow, 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 green, green, yellow. Now, if I want the total probability of drawing at least one yellow, that represents an OR statement linking together all of these. So all I'm going to need to do is take those probabilities and add them all together. 3 out of 55, 3 out of 55, 1 out of 55, 6 out of 55, and another 6 out of 55. So out of 55, we're looking at 3, 6, 7, and 6 is 13, and another 6 is 19 out of 55. And if we crunch that through on the calculator, that's looking at about a 35% chance of drawing at least one yellow in this particular set of data. And that's how we work with a tree diagram. We start at our starting point. For each of our choices, we make our possible outcomes, and then off of that branch, if we choose again, we make another set of branches and another set of branches and another set. We can label them with their respective probabilities and then use that to calculate the probabilities of an event that we're interested in. In the next video, we're going to take a look at one final method for calculating total numbers of possible outcomes that we can then use to come up with probabilities. We're going to look at both permutations and combinations.